It's wonderful to see you. Thank you for being here. And sustainability is about the whole world, and that covers a lot of territory. There's a lot of detail, and we only have an hour together. So what I'd like to do is just give you a sampling by reading short excerpts from some of the chapters from this book. And if you wouldn't mind holding your questions until the end, that will leave us some time at the end that we can have a conversation together. So, what is sustainability? It means enduring into the long-term future. It's about systems that can operate on their own and persist over long periods of time. And the concept of systems is fundamental to sustainability. Why have these systems persisted for so long? The Earth is a mosaic of many different environments at different scales, yet no matter which piece you study, at whatever scale, you see common patterns. There isn't any waste. Energy flows through and materials go round and round in closed loops, with the byproducts from one creature or system becoming inputs or food for another. Things are connected. At every scale are rich networks of connections and interconnections and interdependence, with elements depending on each other and affecting each other. The planet is made of systems that are nested and interconnected at multiple scales. Complex systems are always unpredictable because they behave in nonlinear ways. So these systems are not only more complex than we know, they're more complex than we can know. But it is that complexity and diversity that makes systems resilient. And resilience is the capacity of a system to absorb disturbance and still retain its basic function and structure. Resilience is the cornerstone of sustainability. One idea that's central to sustainability is called the triple bottom line, the three pillars of sustainability: environment, economics, and equity. The environment is our life support system, but it's not the only element if our goal is a system that's sustainable. Humans are not separate. We are all part of linked systems of humans and nature. So the second E is economics. For systems to continue long-term, resources have to be distributed fairly, with each person able to meet their own basic needs. If you're a father living in a rainforest and you know that if things go on as they are, your children will starve, but if you cut down your trees and plant soybeans, you'll get money for those soybeans, what will you choose? If your children are hungry, you can't stop to think about long-term results. But if there were a system where retaining the trees and keeping the stream water clean meant that you could feed your children, you would probably do that instead. Changes to social systems impact the ecological. Changes to ecological systems impact the social. We are part of linked systems of humans and nature. The third E represents equity. Social equity means providing opportunities for all people to grow and flourish in their own way, not just a privileged few. And diversity is a key to the resilience of systems. Whether we are talking about species, people, economies, or landscapes, the more variations there are, the more diverse the components are, the better a system will be able to deal with complexity and remain resilient. The biosphere. Life has been pursuing its way on the planet for 3.8 billion years, and for all but the last few thousand years, it has done that without us. Right outside our doors is a vast living instruction manual. If we read it carefully, we might be able to create positive solutions that work, What do we read there? Nothing about the physical world is static. The entire universe, with us in it, is constantly moving and changing, reusing and recycling, dying and regenerating at every scale, from the great star factories in the arms of spiral galaxies to the microscopic realms beneath our feet. Matter cannot be created or destroyed. Everything must go somewhere. The same atoms are recycled again and again. A carbon atom you just exhaled was flung into interstellar space by an exploding star billions of years ago, then reforged in the furnace of our own star, and along its journey might have built the structure of a bacterial cell 3 billion years ago, been exhaled by a dinosaur 100 million years ago, been pulled beneath Earth's crust, and eventually expelled by a volcano 10 million years ago, circulated through clouds and rain, and been breathed in by an oak tree 100 years ago, all before it moved through you. Material is constantly moving. For every element used by life, there is an intricate and dynamically balanced cycle, ensuring that quantities are always just right for life. At the planetary scale, there are 4 major systems: rock, air, water, and life: the lithosphere, atmosphere, hydrosphere, and biosphere. The biosphere is the thin layer at the surface of the planet where life exists. When we think of nature, we often picture visible creatures we all like: birds, butterflies, pandas. But the big creatures we like live because of things we cannot see. It turns out that bacteria are not only the oldest, most numerous, and most diverse organisms on Earth, they run the planet. Every living system on Earth depends on these tiny, complex beings. The constant flows of energy and matter within the complex network structures of life mean that new forms of life can emerge spontaneously. This is emergence, a feature of all life, in which surprising properties appear in a system that could not have been predicted by focusing on individual parts. Emergence happened in a big way early in the history of life. About 2 billion years ago, the greatest pollution disaster in the history of Earth threatened to wipe out all life on the planet. Ancient bacteria had begun emitting oxygen for the first time, and it began to accumulate. This reactive gas happened to be highly toxic to the life forms then living on the planet. Many species were completely wiped out. But in this early oxygenated atmosphere, in a dramatic example of emergence, some life forms actually developed the ability to breathe this formerly toxic chemical, and the diversity of life began to flourish. All life, at all scales, is made of networks. Whether you're thinking about human brains connected across the internet, or networks of neurons within one human brain, or networks of fungal threads underground, or the networks of galaxies that fill the universe, you could say that life is more about the relationships between things than about the things themselves. The lack of a sharp distinction between individuals and communities is a feature of life. If nature is a complex net of energy connections which concentrate in places to form organisms, the distinction between individual and community is merely a question of scale. This is the basis of the Gaia theory, a field of science now known as Earth system science. In the 1960s, NASA was looking for life on Mars. They hired an atmospheric chemist named James Lovelock to help them design instruments for detecting signs of life. Lovelock studied the composition of the atmospheres of Mars and Venus, and he noticed that there were no chemical reactions going on at all. Then he studied the atmosphere of Earth, and the difference was striking. It was churning with chemical activity. Against all logic, the oxygen level in Earth's chemically unstable atmosphere has stayed within a very close range that is just right for life over hundreds of millions of years. And despite the fact that the sun is burning 30% hotter today than it did when life first appeared, the temperature at the surface of the Earth has somehow remained constant and just right for life as well. All kinds of interconnected characteristics are constantly adjusted, including temperature and the chemical composition of the atmosphere. The planet regulates its temperature by adding and removing greenhouse gases, by adjusting the lightness or darkness of its surface, and by changing the proportions of its cloud cover. It turns out that the whole system, the biosphere, air, oceans, and rocks, work together as a self-regulating, evolving system to keep conditions within the range that is just right for life. Water. Water is a renewable resource. A constant volume of water moves through the hydrologic cycle where it is continually filtered and recycled, and the total volume of water never changes. The problem is not that Earth is running out of water. The problem is that we pull it from the hydrologic cycle faster than it can be purified and replaced, and then we pollute some of the remaining water so it's not safe to use. Where land is left undisturbed, the natural processes connecting water, soil, and living things work together in self-sustaining systems. Root hairs of plants surrounded by thriving communities of fungus and microorganisms separate particles of soil. Tiny animals burrow among the grains and loosen the soil. As roots die and decompose, they leave more spaces between soil particles where more animals burrow. Above, fallen leaves form a protective layer of mulch. Earthworms pull them underground where bacteria break them down. And what began as just powdered rock becomes a spongy, permeable ecosystem perfectly designed to cleanse and infiltrate rainwater. Deep below the surface, water slowly accumulates into pools of groundwater. During dry periods, this water gradually seeps into streams and wetlands, maintaining a steady base flow and providing water to the creatures who live there. Wherever forests and grasslands are replaced by rooftops and roads, this function of the soil is cut off. The vast underground reservoir of water is disconnected from its source. Floods increase, stream banks erode, water quality declines. Streams are cut off from their supplies of water. Fish struggle to breathe in sluggish, low-oxygen water. Water which falls as rain is called stormwater. In the conventional approach to stormwater, concrete and buried pipes take the place of streams. A more sustainable approach cleanses and infiltrates the stormwater with permeable surfaces to mimic the kinds of conditions which would have existed on the land before development, giving water access to the soil. Rain gardens, swales, porous paving, and green roofs replace concrete channels and pipes, letting water soak in instead of running off, making it clean again along the way. The same water has been circulating through the planetary system for millions of years. Our goal for sustainability is to borrow water, use it, and return it to the cycle in healthy condition, ready to circulate again. And we're going to pause for just a couple of seconds